one with finding the distance between 2 points. But today we're going to be talking about finding the distance between two-dimensional points. So instead of just being on that one-dimensional plane like a number line, now we're going to be on a coordinate plane where we could be going left and right or up and down or both, right? So whenever we are looking to find distance between two coordinates, this is our formula. But I want to talk a little bit about where that formula comes from. So this could be some point A and point B that I'm trying to find the distance between. Unlike on a number line, I can't just count, right? Because I'm going over and up some amount to get from A to B. So I would be counting how far over I would have to go and how far up I would have to go. But that's not going to tell me the shortest distance, right, from A to B. The shortest distance is this diagonal line. And this formula finds the length of that diagonal line based on how far over and up you go. If you notice, these two lines I just drew in here make this into a what? A triangle, specifically a right triangle. Good. And I know that in a previous class, you guys have talked about how to find missing links or missing sides in right triangles. Does anybody remember what we used to do that? Very good. Which is a squared plus b squared equals c squared, right? Where c is always your hypotenuse, and a and b are the other two side links, right? Okay, so if we are talking about side A here, that was left and right movement, right? I went from A, moved to the right to get to B. So if I wanted to find the distance from A to B for just the x's, we would use our old distance formula, right? Where you subtract the two values. So that would be your x2 minus your x1, okay? And that is representing A, right? Well, if I plug that into this formula, it says I'm supposed to square A, right? Okay? Plus, if I wanted to find what I would plug in for B. B is this side over here where I'm going up, right? Again, if I wanted to find the length of that line, I would just subtract my y2 and y1, right, to figure out the difference between the two. So y2 minus y1, again, the formula says to square it, is equal to, it says c squared, that side we're looking for, right? But I don't want c squared, I just want c, right? So how do I get rid of a square? Take the square root. And if I take the square root of one side of the equation, I have to take the square root of the other side, right? And this is that formula right there. So that's where it comes from. It's based off of Pythagorean theorem, all right? Okay, so now that we know what the formula means, let's use it to solve a couple of examples here. Example 1 says to find the distance between points 2, 5 and 6, 2. So that would make this first coordinate point like my x1 and y1 from up above. And that would make this my x2 and y2. And all I need to do is go substitute all that information in to the distance formula. So I'm going to have that distance is equal to the square root of x2 minus x1. What's x2 minus x1 for us? What numbers would that be? Very good. So I'll have 6 minus 2, and the formula says to square that, plus y2 minus y1. What are our numbers for that? Good. And the formula says to square that as well. And then we just go in and simplify. So order of operations says we do what first? Inside the parentheses. Very good. So that's where I'm going to start. Okay. So inside of my parenthesis, right here, I've got 6 minus 2, which is 4, okay? And I'm supposed to square it, right? And then here, inside this parenthesis, I've got 2 minus 5, which would give me -3. And I'm supposed to square it, right? Okay. So in that first parenthesis, after we dropped the parentheses now, the next thing to do would be exponents, right? Okay, so what would 4 squared give us? Very good. Okay, and what would -3 squared give us? +9, right? Whenever we square a negative, if you're going to put it in your calculator, make sure you put parentheses around the negative number because it will only square the number, not the negative, if you don't. So +9, and 16 plus 9 is good. And is there a square root of 25? Yes. So the distance between these two is 5 units. All right. Okay, so here they give you another one. Says to find the distance between these 2 points. I'm going to let you guys give that one a try, and then we'll check it together. To y2, so whenever you substitute your information into the formula, what was your x2 minus x1? What were our numbers for that? There we go. So it was x2 and x1, so that would be 2 minus -5. Okay, and I'm supposed to square that. Plus, what was my y2 minus y1? What were those numbers? Good. So -1 minus 3 squared. Okay. So order of operations, just like last time you guys did parentheses first, 2 minus a -5 really means to do what? Add. Good. So we would end up with 7, and I'm going to have to square that. And -1 minus 3 would have given us, and we would have to square that. So I have 7 squared, which is 49, plus -4 squared, which is 16. And what was 49 plus 16? 16. All right, so we ended up with the square root of 65, right? Okay, there is no perfect square root of 65 like there was for 25. At this point, we do try and simplify if possible. So I asked myself, is there anything that multiplies to give me 65 and has a square root? What do we think? No, right? Only thing besides 1 itself, maybe 5 and 13, but neither of those have square roots, right? So this would be as simplified as I could get the radical and keep my answer exact. So this would be my exact answer, okay? If they were to ask you for the estimate, you could type square root of 65 into your calculator and give me the decimal. And approximately what would that be? 6.2, I believe, if we went 3 places, right? Okay, and this one would be our estimate answer. Okay. All right, example 2 says to classify triangle XYZ if these are the 3 points for X, Y, and Z. All right, so in order to do that, we have to know what it would mean if the sides were congruent or not congruent. If all 3 sides were equal, or if all 3 sides were the same size, what kind of triangle is that? What do we call that? Equilateral. Okay. All right, and if 2 of the sides are congruent, anybody remember what we call that? Yes. I think you said it. What did you say?
I'd say isosceles.
Close. Isosceles, yes. All right, and then lastly, if none of the sides are the same, we call it, I remember what we call those. Starts with an S. Any guesses? We call it scalene. All right, so all the sides are the same, equilateral. Two sides are the same, isosceles. None of the sides are the same, then it's scalene. All right, so we need to determine what kind of triangle we have based on these points. Well, our distance formula is going to tell us the length of each side, right? How far it is from one point to the next. If we can just compare the lengths of all the sides, we'll know. So we're going to start with xy, the side xy. So that would be the point that goes from here to here. So my x2 minus x1 would be what? What's x2, guys? And what's x1? So what does 5 minus a negative 3 really mean? Plus, yes. Yes, we will get 8. So 5 plus 3 squared. All right, and then what's y2 minus y1? What numbers are those for us? Good. Negative 7 minus 6 squared. All right, you guys said 5 plus 3 would give me 8 squared. Okay, and then negative 7 minus 6 would be 13. Okay, so what is 8 squared? 64. And what's 13 squared? 169. Okay, and what's 64 plus 169? What is it? 233. All right. All right. Okay, now we're going to find the length of y to z. So now y is going to be my x1, y1. Z is my x2, y2. All right, so what would be my x2 minus x1 this time?
1 minus 5.
Very good. So I got 1 minus 5 squared plus, what's my y2 minus y1? Very good. 4 minus a negative 7, which would be the same as 4 plus 7, right? Okay, and what is 1 minus 5? Negative 4, and 4 plus 7? 11, and then we got to square those, right? So what is negative 4 squared? 16, and what's 11 squared? 121. So what's 16 plus 121? Very good. So I have the square root of 137. Okay, so far we know that it's definitely not equilateral, right? But we need to see what that third side is. So now I'm going to compare sides z and x. So now this is going to be my x1, y1, and this is going to be my x2, y2. All right. So what would my x2 minus x1 be? Very good. All right. And what would my y2 minus y1 be? 6 what? 6 minus 4. Good. All right. And then I just need to go back and simplify. All right, so negative 3 minus 1 would be negative 4, okay? And I'm supposed to square that. And what's 6 minus 4? 2. Okay, so we got negative 4 squared, which would be 16, and 2 squared, which would be, and 16 plus 4 is 20. All right, so were any of my sides the same? No. So I would have to say triangle XYZ is what type of triangle? Scalene. Good. All right. Okay, now I'm going to let you guys try this one. You can work with the person beside you if you guys want to take turns who's doing what, and you can share answers with each other, and we're going to check what we get here in just a moment, okay? Can somebody share with me what you guys got as your results? Scalene, yes. All of these are different sizes. and it's a triangle XYZ. So triangle XYZ is scaling. Good. Okay. If you will flip it over onto the back, all right, now we're going to talk about finding the midpoint. So remember, our midpoint is the point that falls right in the middle, but instead of looking at how far apart or how far away it is from something, I'm going to be looking at exactly where it's located. So that means I'm going to need an x value and a y value since it's a coordinate point, right? We still do the exact same thing as before. You average your x's, you average your y's. So you add them together and divide by 2, all right? We do have an additional formula that says you can use the formula we did for fractional coordinates in the last unit, but again, you'll have to do it for the x's and you'll have to do it for the y's because we need an x and a y value. So since we just want the midpoint, our k will always be 0.5, right? Because we're always going halfway. But it's the same formula from last unit. You just do it for x and y. All right, so the thing here is, in this formula, you do have to determine if you're going to use plus or minus, but obviously we don't only move left and right on a coordinate plane, right? So if you're determining if you should move if you should use the plus or minus, it's determined on which way you're moving. Obviously, we know if you're going towards the right, you use the plus. Okay? You also would use the plus if you are moving up. So if you went up when you're doing your y values, you would use plus. Okay? But for minus, we already knew that that meant you must be moving towards the left. Okay, for your y's, that's going to mean you must be moving down. Okay, so let's look here at example 1. It says to find the midpoint of AB. So this would be my x1, y1. This would be my x2, y2. All right, so maybe on this first one, we use that first formula from up above. This one here, where it says we just average the x's and average the y's. Okay, if that's the case, for my midpoint this time, I'm going to have x2 plus x1, and my numbers would be what for x2 and x1? So the formula says plus, right? So it would be 5 plus -2. Good. All over 2. Okay, and then for my y's, what is y2 plus y1 going to be? Good. I'll have -4 plus 4 all over 2. And then I would just simplify. Okay? So, my midpoint for x, I've got 5 plus -2, which is what? 3. And 3 divided by 2 is 1.5. So the x value is 1.5. All right, and then my y's, -4 plus 4 is 0, and 0 divided by 2 is 0. So the midpoint between these 2 points would be at 1.50. Okay. All right. On this one here, it says to find the midpoint of CD. Okay, so again, we've got some x1, y1, and x2, y2. But maybe this time we're going to use that second formula. Okay, so I'm going to start with my x values. So midpoint here, the formula up above says we're going to use x1. What's our x1? -6. Good. And then it's plus or minus. Remember, we have to determine, are we going to the left or are we going to the right? To the right. So we're going to use plus. Okay. Our k, which if we're doing midpoint, we're going halfway, so 0.5. times the absolute value of x2 minus x1. What's that going to be for us? Very good. 8 minus -6. Good. Okay, and then we have to do the y value as well. So I start with y1, which is -7. And then are we going up or are we going down? Up. So I would use plus 0.5 times the absolute value of y2 minus y1, which would be 1 minus -7, right? Okay, and then I just simplify. So I'm going to go back over here. I simplify inside first. We know 2 negatives really means to add, right? So 8 plus 6 would be 14, right? And the absolute value of 14 is 14. 14 times a half is 7. So I have -6 plus 7. Over here, again, 2 negatives really mean to add. So I got 1 plus 7, which is, and the absolute value of 8 is just, and 8 times a half is 4. So I have -7 plus 4. Okay? So what is my x value? 1. And what's my y value? Very good. So the midpoint would be at 1, -3. So unless they specify which method to use, you can pick, okay? But we do need to know how to do both. This one is going to be important when we're not just going halfway, right? Okay. All right. One last one here on this page. It says, find the midpoint of a segment whose endpoints are A, B, and A and 3B. So this is x1, y1, and this is x2, y2. All right, so maybe we use this same formula again. So for midpoint, I'm going to have A as my x1, right? And it appears we did not move in a negative direction. There's no negatives there, so we would say plus 0.5 times x2 minus x1. So for us, that'd be A minus A, right? All right, and now we're going to do y. So I start with my y1, which is B, plus 0.5 times the absolute value of y2 minus y1. What was our y2? 3b. So I'll have 3b minus b. All right, and then we just go back and simplify. All right, so what is a minus a? 0. And what's 0 times a half? 0. So it's really a plus 0, which is just a. Yeah, we're just going to have a there. All right, and then here, 3b minus b is 2b. And what's half of 2b? 1b. So I have b plus b. Well, like you guys said, a plus 0 was just a, and b plus b is 2b. So the midpoint would be a, 2b. All right. Okay. Flip it over onto that last page there. All right, example 2 says that M is the midpoint of the segment XY. So this time it's a little different. They gave us the midpoint. They want us to find the missing coordinates for Y. All right, so we had that formula on the front where we said we just average our X's and Y's. So I'm going to use this formula and just plug in what we know. So I know that midpoint is equal to all of this, right? Okay, and they gave us the midpoint, right? They gave us the answer. What did they say the midpoint was? Okay, so apparently whenever you work this whole thing out, you end up with the answer -4, 7. Okay, they also gave us the coordinates for x, which is the first point here. So that must make x my x1, y1, right? So I'm going to substitute in that information to this formula. So I don't know x2, right? That's still an unknown. That's what we're looking for. So I can't put anything in for x2. But what can I replace x1 with? 3. All over 2. And then over here, I don't know y2, but I can replace y1 with -2. All over 2. All right. So what's important to notice here is that this part is what gives me this number, right? And this part is what gives me this number. So I could take this piece and set it equal to -4 and solve. I can take this piece, set it equal to 7 and solve. So if I had -4 is equal to x2 plus 3 over 2, what would we want to do first here to get rid of that fraction? Multiply both sides by 2. So I multiply this side by 2, it cancels out. I multiply this side by 2. And what is 2 times -4? So I got -8 equals x2 plus 3. Then what would I do? Subtract 3. So what's x2? What is it? -11. Alright, and then I would just do the same thing for the y value. So my y was 7, so I'm going to have 7 is equal to y2 plus -2, or just -2 over 2. Again, how do I get rid of the fraction? Multiply both sides by 2. So 2 times 7 gives us, very good. And then what should we do? Add 2, and we end up with y2 is equal to 16. Very good. So that would mean that the missing coordinate for y is at -11, 16, right? Okay, so let's think about that for a second. Let's see if that even makes sense. So if this was my coordinate plane, my midpoint I said was at -4, 7, so that'd be somewhere over here, right? Okay. All right, and then I also had x being at +3, -2, which would have put me somewhere over here. Okay, so then I should have automatically known that meant y had to be somewhere up here, right? If that makes m the midpoint. I also could just calculate how far did I have to move to get from here to here, and how far did I have to move to get from 7 to 2, right? Oh, sorry, I had my negative signs on the wrong spot on that point, sorry. 3, -2. All right. So how far would I have to move to get from -4 to +3 on the x-axis? How many points is that? How many points is that? From -4 to +3. 7. Good. Okay. So I went to the right 7 to get here. I would need to go to the left 7 to get to my y, somewhere up here. And negative 4 minus 7 is what? Negative 11, which is exactly what we have here. To get from 7 down to negative 2, I'd go down 9 places, right? So I would have to go up 9 places to get to my y. 7 plus 9 is 16. So it does make logical sense that this would be our coordinate point, okay? All right. I want you guys to try example number 3. Okay, so this is what we should have set up, right? So that means I can set negative 5 equal to x2 minus 3 over 2. What did you guys do to solve that? Multiply both sides by 2. Good. So whenever I multiplied the left side by 2, what did we get? Good. So I got negative 10 equals x2 minus 3. Then what do we do? Add 3. Negative 10 plus 3 would be what? Perfect. Okay, so I got my x value. Now I do the same thing to find the y value. So I'm going to have 2 is equal to y2 plus 4 over 2. Again, you multiply, right? So I end up with 4 equals y2 plus 4, right? Then what should I do? Subtract 4. We end up with y2 is equal to 0. So the missing coordinates for y would be at perfect. And you're always welcome to draw yourself the coordinate plane to see if that makes logical sense.